Hi, I thought it might be good to do the next module. So here it is, Module 2, the Relational Model Introduction, QBE, which stands for Query by Example, and Relational Algebra. Let me move over there so I can actually see it. So these are the learning objectives. We want to describe what the relational database model is. We want to explain what QBE is. How do we use criteria in that query? We want to create calculated fields. Instead of just data, we want to be able to calculate sums, minimums, maximums from the existing data. We want to summarize data. These are aggregate functions, again, like sum, min, max. We've got a bit to sort. We want to be able to join tables. Now, joining means we need to connect two or more tables together somehow. And we want to update data in tables, and then we want to apply the relational algebra. So, in a relational database, it's a collection of tables. Now, formally, in the language of relational algebra, a table is a relation. So it's going to be a little confusing. You may remember last time I talked about relationships. That's the connectivity between relations, between tables. Each entity is stored in a table, right? So remember, an entity, a table, contains a real-world thing or concept, usually. Sometimes a real-world thing or concept is only an attribute. It's a little bit small, but at a high level, tables are things in the real world. And I'm going to be using the JCC database. I have given you access to the other two databases, but I don't want you to use them for any of the Cengage assignments. So just do the Cengage assignments that I link to in Blackboard. There's lots more assignments in Cengage than I want you to do, or that we have time for you to do. So just do the ones that I pick out. And the JCC database has a table for employees, for clients, I think it has projects, and the attributes of an entity become the fields or columns. So entity, table, relation are pretty much the same three things. And attribute, field, or column are parts of those entities. They're also can be used interchangeably. The employee table has an employee ID, an employee name, first name and last name, etc. Okay. So there's a few relationships between tables. For example, there's a one-to-many relationship between clients and projects. Each client can have many projects. And how is that relationship implemented? Well, we use a particular field. Usually it's an ID field, so that the project table has a client ID, and that client ID is unique, will uniquely identify a client in the client table. The fact that that key, that client ID attribute, I'm going to call it a key, the fact that it's unique means that we can use that key, that attribute, as a primary key. A primary key is one or more attributes that can be used to uniquely identify a row in a table. It's a primary key. So that's why it's saying here each column in the table should have a short but descriptive name, and it should be unique. Entries should be consistent, and each row should contain information for the new item. So a relation is a two-dimensional table. It's got rows and columns in which the following are true. The entries are single valued. Right, so for a given row and column, there's only one value. Each column has a distinct name. All the values in a column are values of the same attribute. That is, they must match the name of that column. If it's street name, then all of those entries in that column should be street names. The order doesn't matter. You can add or you move them around, it doesn't really matter. Each row should be distinct, and again the order of the rows doesn't matter either. So a way to do shorthand to describe a table is you write the name of the table, and then after that in parentheses you write a comma separated list of the names of the columns or attributes of the table, and each table should appear on its own line. So sometimes you may end up having duplicate column names, and if that's the case, for example, customer, maybe customer has a field ID, and maybe project has a field ID. We didn't use customer ID and project ID. So both of those entities, both of those tables have a column called ID. So if we need to distinguish between the customer ID and the project ID, then we write both down, so customer.id or project.id when we want to distinguish between the two of them. So all that's doing is qualifying the column name with the table ID. It's always acceptable to qualify column names. Sometimes you don't need to, but it's always acceptable. It makes things unambiguous if you do qualify each column name with its table. So for some of what we're going to do, we're going to be using Microsoft Access. And Microsoft Access has a nice interface that allows us to form queries on our database using a GUI, a graphical user interface. And all we have to do is drag columns around and maybe enter some information in fields, and we can change sort order and filter the data based on a particular attribute of a table. So that's the nice thing about it. So to do that, we can click on the Create tab, and I'm going to do another video where I'm going to work through this. I'm just going to quickly talk through it here, and then I'll use Access to do this later. And then we can use the Query Design button and use the Query Design view. We can show table, we can add things. It's relatively straightforward and pretty easy to manipulate. So here's an example, or here's the a screenshot, right? So here we've got the design, and we've got a query, and we're querying on the clients table. And this upper pane shows all of the tables that we're using in the query. This only has one table, but it doesn't have to only have one table. This lower pane selects the fields that we're going to be using, we're going to be outputting from our query. When we just get information, it's just a read information, that's usually called a select in database speak. So that's why that select button is pressed. And I think that's about all we need to know, really. The run button just executes the query and shows you the result of the query. So I'll try doing that on under Access a little later. And I'm not going to read through this. I'll do this in Access later. So when the things you're trying to find or extract from the database must satisfy a particular condition, that's usually called a criterion. Right? If there's more than one criterion, then the plural is criteria. If you plan to use a query lots of times, then it's best to make the query with a parameter, so you can pass that parameter in as it changes from run to run. And then normally you want to use one of these there's a not equal sign, it's a less than sign. I can't quite reach over there, but that's greater than, less than or equal to, greater than or equal to, or equality. Okay? And you can that's if the value is numerical. If it's just a text, then probably the only ones you might be interested in, unless you're interested in alphabetizing or alphabetical order, probably the only things you'd be interested in if it's a string would be equal to or not equal to. Sometimes you want to apply multiple criteria, so you use the AND operation, which says that each criterion must be true before a record is selected. The OR operation says that only one of the two criteria on either side of the OR need to be true for it to be selected. And you can put as many of those together as you like. I'll show you what that looks like in a little while. Right, so here's an example of how to do it in the graphical view. Here we've got the task master list, and we want to pull out the task ID, the description, the per and the estimate, and we want the per to be hour. As you can see, that's what's selected in the criteria row, and because both of these need to be true, we want the estimate to be greater than or equal to 150. Right? If we wanted it to be either the per is set to hour or the estimate is greater than or equal to, sorry, it's a less than, isn't it? Less than or equal to 150, then we need to do a separate condition. the or you can see over here. There's an or compared with both of them being on the same line here, right? We didn't use the or row in the previous one, so that's an and that's an or. Sometimes you need to be able to calculate fields, as I said earlier, sum, minimum, maximum. Maybe you want to calculate a discount based on the discount percentage. You want to try and avoid letting the user do that, because the user is probably prone to error, so you want to be able to put that in the computer, in the database, rather than have somebody enter it. Okay, so in Access, you generally want to put the field name in square brackets like that, and that makes it easier to have names that contain spaces, etc. But it just makes it very clear what field you're referring to. And most of that, the rest of that I'll demonstrate rather than just read through what's on the screen. Right, so here's another example of a calculated field. Somewhere in the database there is a monthly salary, and what this query is doing, you can see it's a query because it's got query 1 up here. What this query is doing is it's pulling out the information from the probably the employee database, and rather than showing the monthly salary, it's multiplying that monthly salary by 12 and renaming it as annual salary. It looks like it's chopped off there, but I think it says annual salary there. Other things you might want to do apart from summing, you might want to count the number of people, right, who have a salary, an annual salary greater than, I don't know, what was the number, greater than $90,000, right? I think that might only, there's one person there, there's another person there, another 2 there, so that might give us a count of 4 if you use the count keyword. But there are others there: average, count, max, min, sum. Those are not just multiplying the salary by 12 like the previous example. These are summarizing or aggregating information. Okay, so the average will take all of the values, add them up, and divide by their number to find the mean. Count will just count how many there are in the list. Max will figure out which is the largest one. Min will find which is the smallest, and sum will just add them all together. Sometimes you want to do those aggregate functions over the whole table. Sometimes you don't. Sometimes you only want to group those aggregates over particular criteria. So you can do that, but you need to make sure you group them using the where keyword. And again, I should do an example of this for you. Okay, so here's an example where we're getting the sum of the salaries, where the hire date was less than January 1st, 2020. Right, you can see the total there being used is sum. That's the aggregate we want to use, and that's what that's doing. You may want to sort. If we have a look at that, right, that query there didn't really seem to have a sorting on the fields, right? They're not sorted by last name, they're not sorted by title, and they're not sorted by annual salary. That makes it a little hard to read, right? So you might want to sort things. And you can sort by any of those fields or any combination of one or more of those fields. And you may need to check what the primary sort field should be and what the secondary sort field should be. For example, you could sort first of all by salary and then by name, right? In case two people have the same salary, then you want to decide what order they're going to be in within that single salary. And then I think the last main piece in this is joining tables. Here, this is where you've got two tables and there's an ID in one that is also in the other, right? So you need to join, you need to have a common field, that's what this is saying, in order to connect those two tables, to form a relationship between those two tables. Normally, and again, there is a relationship editor within Microsoft Access that makes it pretty easy to add those relationships in. I've talked about one-to-many. There's more different types of relationship, right? Normally you can have a one-to-one. So for every client, there's only one client address, for example, if the client address is in a separate table. Or you could have one-to-many, right? For every client, there's many projects. Or you could have many-to-many. If you have multiple projects and multiple employees, and each employee can work on multiple projects, then that's potentially a many-to-many relationship. Normally it's better not to have many-to-many relationships. Sometimes you have to have them. We might talk about what to do in that case a little later. But normally you've got a one on one side of the relationship. It's either one-to-many or one-to-one. And when you do that, that one side should have a primary key. Like, remember, a primary key is something that uniquely identifies a single row in the table. And we can set that up in Access to make sure that a particular field, and usually it's an ID field, is a primary key. It is unique within the table. Okay, so there's an example of a relationship between employees and projects. One employee can work on many projects. And this is a query where we're looking for the project start date after January 1st, 2021. But we want to pull out all the employees and the project ID and the project start date. So we need to join those two tables together, and we do that using the employee ID field. You can see that one-to-many is coming from the primary key. You can see there's a little key beside employee ID. So that's the primary key. There's a 1 here, and it goes to the same named field over here, employee ID, but you can see there's no key here. The key on the projects table is the project ID. Usually it's a good idea to name your primary keys with key or ID, something like that. Number sometimes, just so that it's clear. Mostly we've talked about just doing a select or a read, but other queries that we could make will change the data in the database. And the big issue with changing the data is databases don't have an undo feature built in. You can make them have an undo, but you need to be very careful when you do what's called an update, because the data that was there will disappear. And the way I usually do my update queries is before I do the update, I do a select query using pretty much the same criteria as what I want to do with my update, and check on the database that it's returning the rows that I think it should be returning. And once I'm happy that it does that, then I change it over to an update query and make it update. Delete also will delete a whole row in a table, or more than one row in a table, and it can't be undone, so you have to be careful. If you just run delete with no criteria, then everything in the database disappears, in that table disappears. So you want to be very careful when you use a delete operation. Normally when you do a select or a read query, the information just comes out in text. But sometimes you want to store that information in a new result table, for example. And that's what the make table query is about. It takes the data that you created and it puts it into a new table. Obviously you don't want to keep doing that, because if you keep making lots and lots of new tables, it's going to fill up the database pretty quickly. But it may be required as if the query is an intermediate result between others. There's a rule in software engineering that premature optimization is evil. And to a large extent that's true, because people want software to be efficient. And so they often put a lot of effort into making the tools, like databases, efficient. Now there are some things you need to do for optimizing that don't get just done automatically. And for that case, there is a query optimizer. But in general, 80% of the time, you don't need it. 20% maybe you do, maybe 10%, maybe 5%. But it does allow you to... The main reason you would use a query optimizer is if your query is too slow. And too slow really depends on the application. What it means depends on the application. Okay, I'm not going to talk too much more about relational algebra. In fact, this textbook doesn't talk really much about relational algebra at all. I might release some notes to show you a way to do it. But I think we're better off just moving straight to Access and straight to SQL. But SQL does have select, does effectively have project, obviously has a join, there's a keyword union. I don't think there's a keyword intersection, but we can certainly form intersections. And then there's subtract, set subtraction, set product, and then maybe we want to rename stuff. Okay, a relational database is a collection of relations, tables, entities. An unnormalized relation is a structure in which a field may have multiple values. A field name can be qualified by preceding it with the table name and a period, in case we have the same name on two different tables, same attribute or field name on two different tables. And a table's primary key is that field or grouping of fields that can uniquely identify a given row. And Microsoft Access is a nice query by example visual tool. And criteria are ways to filter the data, reduce the amount of data we return that satisfy a particular criterion or group of criteria. We may want to create a calculated field or an aggregate function. Calculated field like that 12 times monthly salary to get annual salary. Aggregate functions like average, sum, minimum, maximum, and count. We may want to sort fields. We may want to join, delete, or update or modify data in tables. And we talk briefly about the relational algebra. That's it. Next video will be a brief run through probably the JC consulting database in Microsoft Access.